Okay, this video is about area between two curves and rotating that region around certain axes to create a solid revolution. Okay. So on the final exam, they'll usually group these two types together. So I'll try to imitate that in this video. So first of all, they'll ask you find the area between the two curves. So that's upper curve minus lower curve. And then afterward, they'll ask you to rotate that region around certain axes. So they'll ask you to rotate it around more than one axis. And usually not the x and y or y axis. So you have to know how to manipulate those, and I'll show you that in a bit. And then yeah, so usually they'll just ask you to rotate around like 2 or 3. And then just remember, it's just adding up areas of circles, literally. So it's just pi integral of r out squared minus r in squared. Okay? So for this one, we have f of x as square root of x, g of x as 6 minus x. We want to find the area of r, and r is the region bounded by f, g, and x axis. Okay? So let's draw this little region out first. So square root of x looks something like that, and 6 minus x is just a straight line that looks something like that. And here's our region R. Okay. So when we're looking at this region, do we want to integrate with respect to x or y? Now, this one doesn't matter too much to find the area, but if you do it with respect to x, we need to split up into two integrals because the upper curve changes. The upper curve for everything up to this point right here is the square root function, the lower curve is the x-axis, and afterward the upper curve is the straight line, and then the lower curve is the x-axis. So that's why we need to have two integrals. If we integrate with respect to y, we flip our graph over, we see that the upper curve is just a straight line all the way up, and the lower curve is just the square root function. Okay. So I'll do both. So with respect to x first. First of all, let's find this point of intersection. Well, it's probably going to help. So square root of x is equal to 6 minus x. Okay, so x equal to 36. I'm squaring both sides, by the way, minus 12x plus x squared. So 0 is equal to 36 minus 13x plus x squared. So 0 equals to x minus 9, x minus 4. Okay, so x is equal to 9 and 4. Obviously 9 does not work because square root of 9 is 3 and 6 minus 9 is minus 3. Or technically this is minus 3. If this is minus 3, that'll work, but it doesn't matter for us in this case because this point right here is what matters to us. So that is when x is 4. So when x is 4, then y is equal to, so plug back in, 2. Okay. Now, to find the area, we need to stop the integrals of upper curve minus lower curve. So this is from 0 to 4. Again, this is with respect to x. Look at the x points. Upper curve, square root of x, minus lower curve, which is minus 0, because it's the x-axis. dx. Okay, plus integral from 4 to 6, because 4, and this point right here is x equals 6. Okay. It's just upper curve is 6 minus x, again lower curve is 0, so dx. And both of these are simply just parallel, 2/3 x to 3/2 from 0 to 4, plus 6x minus half x squared, 4 to 6. Okay, and this is simply just, so it would be 16/3. Is that right? Yes, and then this is plus 36 minus 18 minus 24 plus 8. Okay, and this is equal to, when you simplify it, it will be equal to 22 over 3. Okay, now let's integrate with respect to y. Okay, so again, we said that our upper curve is the linear function and the lower curve is the square root function. Now, the problem is this in terms of x. y in terms of x. We need x in terms of y as a function. So for y equals to square root of x, this becomes y squared is equal to x. Okay? And then y is equal to 6 minus x. This becomes minus y plus 6 equals to x. Okay. So we take our y bounds, which is from 0 to this point right here, which is y equals 2. Okay? So 0 to 2. Of our up curve, which again we said was the linear function, so now we need it in terms of y, so minus y plus 6 minus a lower curve, which is y squared dy. Okay? So let me look this up. This is simply just the power rule, so minus half y squared plus 6y minus 1/3 y cubed from 0 to 2. So this is just, let me check this right first. Yep, okay, so this is just simply plug in 2, that would be minus 2, plug in 2, that would be 12, plug in 2, that would be minus 8/3, and simplify this, it will be 22/3. And you see that this matches up with this one. Very good. Okay. So now, we found the area between the two curves, found the area of the region. Now let's rotate it. Okay. So if we rotate it about, let's say, y is equal to -1. Okay. Where is that? Well, y equals -1 is down here. Okay. So because it's a horizontal axis, we probably want to integrate with respect to x, so we have no choice but to do it in two separate integrals. Okay. So for y is equal to -1, we need pi integral of, so for up to here, r out and r in we have to figure out. So r out is just simply the longer line that you draw from the axis of revolution to the function. Okay, so r out, as you can see, this one's longer, so this r out is a square root function. R in is the x-axis. Okay? Now, the length of the radius, though, it's not just the function itself, as it would be if it were rotated around the x-axis. We're rotating around axis y equals to -1. Okay, so there's an extra factor of 1 right here in the radius, as you can see. So it's the function plus an extra factor of 1. So r square root of x plus 1 squared, okay, see right there, minus rn squared. Rn is right here, which is just 1 squared. Dx plus, same thing for the second integral, pi integral from, what's that, 46. Okay, so I'll show you that in a bit. And then again, r out, r in. So r out is the linear function, so 6 times x. And then we have to add 1 because of the extra little length, minus 1 squared again. Dx. Okay? So this is simply just simplifying, and then the power rule of this bound should be from 0 to 4. Sorry about that. Okay. So 0 to 4. I'll show you why. It's 0 to 4 up here. Okay. So 0 to 4 of x plus 2 square root of x plus 1 minus 1, so this is dx, plus pi from 46 of, when you simplify, that would be 48. Right, so that's 749. Yep, 48 minus 14x plus x squared dx. Okay, this is simply just the power rule, so pi times half x squared plus 4/3 x to 3/2 from 0 to 4 plus pi times 48x minus 7x squared plus 1/3 x cubed from 4 to 6. Okay? And I'll leave you to do the fundamental theorem of calculus and algebra. Okay, so that is the setup. Okay. Now what if we want to rotate it around x equals 7? Okay. Well, I'll sketch the region over here. Let's square it like that. Region R. Okay. Rotate it around x equals 7. X equals 7 is right here. Okay. So because we're rotating around a vertical line, we probably want to integrate with respect to y. Okay. So it'll be pi integral. So again, if we integrate with respect to y, we see that the upper function and the lower function do not change. Okay. So we look at our axis of revolution. We need r and rn. So what's r out? Obviously this one's longer, so r out is the squared function, and rn would be the linear function, okay? Now what is the length of the radius though? That's the thing. Okay, it's not just a function itself again, because if it were, for example, so the functions are x equal to y squared, and then x is equal to, what was it, 6 minus y, okay? So the length of this radius would be 7 minus y squared for this radius. Okay, why is that? Well, the length of this radius from the x and from the y-axis is y squared. Okay, and then the length of this radius from the y-axis to x equals 7 is 7. Okay, so 7, the whole thing, minus this part right here, which is the function x equals to y squared. Okay, so r out is 7 minus y squared. Then we square that. It's r out squared. Okay, minus rn. So same thing. This is the length of the whole thing. So that's the length of 7 for the whole thing. Okay, minus the length of this part right here. That's missing, which is the length 6 minus y, so it'll be 7 minus 6 plus y, because 7 minus, in parentheses, 6 minus y, squared dy pi, and oh, sorry, I forgot the bounds, from 0 to 2, because we established that this point was 4 to 2, so 0 to 2. Okay, from 0 to 2. So now we have to expand and then combine like terms and all that good stuff. 49 minus 42y squared plus y to the 4th. Okay, so this is just 1 right here. So this is minus 1 minus 2y minus y squared dy. Okay, so we can see, so this is 48 minus 15y squared minus 2y plus y to the 4th dy, and this power rule again, 5y cubed minus y squared plus 1/5 y to the 5th from 0 to 2. Okay, and I'll leave you to do the simplification also. Okay, but here's the setup, and this is basically what they'll ask you. So again, find the area of the region, and then rotate it around the axes that they give you. That's what this problem asks too.